Pesticides, including insecticides for insect pests and herbicides for weeds, are part of a cotton grower's pest control toolbox called Integrated Pest Management, or IPM. With IPM, growers aim to choose the tool that best controls pests with the least risk to human and environmental health. All pesticides in Australia are assessed and approved by a government regulator. If a grower chooses a pesticide to control a specific pest, it is safe to use as directed by the label. Australian cotton growers reduced insecticides by 95% per hectare between 1993 and 2019, as genetically modified cotton and IPM was introduced. IPM has also seen growers make more use of good beneficial insects to control bad pest insects. Over the same period, a reduction in tillage to control weeds has increased herbicide use by 20%. But less tillage has increased soil moisture and organic matter and reduced fuel use. However, because the active ingredient in each pesticide varies in its toxicity to different plant and animal species, measuring volume applied is not a good indicator of environmental impact. Environmental toxic load, or ETL, combines the amounts of pesticide active ingredient used per hectare per year to summarize the toxicity to 4 different indicator species: bees, algae, fish, and water fleas. ETL will reduce over time if less of the active ingredients are used per year, or if different active ingredients with lower toxicity to an indicator species are used. To make reporting a little simpler, we've chosen to report the ETL for bees and algae, as they are indicators of the hazard from insecticides and herbicides, respectively. To show how ETL is used in the cotton industry, we've calculated the ETL for the herbicides and insecticides an average suburban household might use as a comparison to cotton industry ETL. In our example, these 2 households use the same herbicide on their lawn and the same insecticide to control cockroaches. But to control termites, House 1 chooses product that is reapplied every 8 years, and House 2 chooses a product with slightly higher toxicity that is reapplied every 4 years. When we calculate the total ETL for our example suburban house and the cotton industry, we can see the cotton industry's ETL for algae is much higher than the houses. This is because herbicides are often sprayed across whole paddocks on a farm to target a wide range of weed species, but weeds are spot sprayed on a suburban lawn. Farms also use a mix of residual and knockdown herbicides to prevent weeds building resistance to a single type of herbicide. Residual herbicides remain active for weeks or months to act on successive weed germinations, and so have a higher hazard than knockdown herbicides that are short-lived and target only weeds present when sprayed. We can also see cotton's ETL for bees is much lower than the suburban homes. This is because the active ingredients applied to an average cotton farm per hectare per year are much less toxic to bees than the active ingredients applied to these average suburban homes per hectare per year. And we can see House 1's product choice gives it a much lower ETL for bees than House 2. So that means House 2 is worse for the environment, right? Well, maybe not. It's really important to understand ETL is a measure of hazard, not risk. A hazard is something that can cause harm. For example, driving a car is hazardous. A risk is the chance a hazard will actually cause harm. The risk of harm from driving a car is low because drivers must follow safe road rules and wear a seatbelt. This risk of harm from pesticide application is similarly low because farmers must follow safe application directions on the label and wear personal protective equipment. Just like driving a car, these steps reduce risk to themselves and others. House 2's insecticide active ingredient has about the same toxicity to bees as the product chosen by House 1. But because it needs to be reapplied twice as often, House 2's ETL for bees is about twice as high as House 1's. So, House 2's choice presents a higher hazard to bees. It has a higher toxicity to bees per hectare per year. But, and this is super important, the risk of bees actually ingesting the pesticide around the house is low for both, if the products are applied as directed by their labels. So, ETL can be used to measure changes in hazard. The Australian cotton industry's ETL has reduced significantly over time through the choices made by growers and technological developments made by scientists. ETLs help us see which products pose the greatest hazard to the environment, which can help identify if changes are needed, even though the actual risk posed by a pesticide will always be low when applied as directed by the label. For example, most cotton seeds are coated with an insecticide to prevent soil pests eating the seed when it is planted. This contributes to the ETL hazard for bees, but because seed is buried, the actual risk to bees is thought to be low. In some ways, risk is more important than hazard. However, we've chosen not to measure risk for two reasons. First, risk is hard to measure accurately, whereas hazard can be calculated by estimating how much of each chemical was applied per hectare per year. Second, and more importantly, pesticides used in Australia are already assessed for risk and approved by the APVMA, Australia's respected, scientifically proficient regulator. All pesticides are assessed for their safety to humans, off-target species and the environment before they are registered for use. So any pesticide a grower chooses is safe to use as directed by the label. Measuring ETL gives us another tool to responsibly use pesticides, on top of the regulator's risk-based decisions and the careful choices by growers within their IPM toolbox. It also gives a more accurate picture of environmental impact than total volume of chemical use, which is also reported for context and transparency.